For this section, we're going to look at solving percents using equations, okay? So don't get too bent out of shape about equations. We haven't officially talked about algebra yet, but we've had little bits and pieces of it here and there. So we've talked about algebra throughout this course. We've learned about evaluating algebraic expressions, and then when we were talking about proportions, we learned a little bit about algebra and equations there. So again, this is not going to be like full on solving equations, but it's just enough. We're going to have just enough algebra here to do what we need to do. Okay. So don't let the word equation get you upset. All right. Now we do need to remind ourselves from the previous worksheet that percent is a way to represent part of the whole where the whole is specifically 100. Okay. In fact, we defined percent as parts per 100. So percent means parts per 100. But here's the deal. Generally speaking, in most cases, we need to find a percent of something where the whole is not exactly 100. That would be great if this whole world was broken down into units of 100. Things would be so easy, but that's not always the case. So if you are asked to find a percent of something where the whole is not exactly 100, what do? Well, we have two methods for how to do this. We can use equations or we can use proportions. And if you think about proportions, that should kind of make sense. Okay, if you're dealing with a percent, which means parts per 100, but you have something where you're not dealing with exactly 100, there should be some proportional relationship that exists between those two things. So we can definitely use proportions, which we will for sure use in the next worksheet. But for this worksheet, we're going to focus on equations, okay? And again, not deep algebra. Everything we've learned up to this point is going to be plenty of algebra to get us through this section here. Okay. Now we do need to understand percents, but we already kind of understand percents. We focused a lot on just what is a percent in the previous worksheet. So here we're really focusing on understanding percent problems. And it just so happens that percent problems have three really important parts. One, of course, is the percent. Okay, if you're dealing with a percent problem, there's going to be a percent somewhere in that problem. The other two parts are they're kind of new to us, and they're sort of easy to confuse. So you really need to have a strong understanding of these next two parts, okay? So we have the base, and then we have what's called the amount. So let's talk about the base and the amount, okay? So under definitions, we have that the base is the entire quantity being considered. So whatever the scenario is, let's say we're talking about cars on a car lot, okay? All of the cars on the car lot is the entire quantity being considered. That would be the base. If we're talking about students in a classroom, all of the students in the classroom, the entire quantity being considered, the base, okay? So we just have to sort of understand like what we're talking about and what is everything we're talking about. Everything we're talking about, that is the base, okay? Now, what we end up doing is we take the base and we multiply it by the percent. So you need to understand that whether we do the equation method or eventually the proportion method, you take the base and you multiply it by the percent. Okay. And a lot of times in math, there's a key word that we can look for. Now, I caution you, this is a very common word that is used all the time in the English language. Every time you see this word, it does not mean multiply, but in the right context, it can mean multiply. So the word of, just plain old OF, oftentimes means multiply. So a lot of the time when we're talking about these problems, especially when we're talking about something really generic without like actual objects or people or places assigned to it, you can use the word of to indicate, hey, this means multiply, so this would be my base, okay? Now, next up, we have the amount. The amount is some portion of the base, okay? So this ends up being the result after the base has been multiplied by the percent, okay? So we take the base, we multiply it by the percent, and that's going to equal the amount, okay? Now, just like in the previous definition, we had the word of. Okay, in this part, we have the word is. Okay, so is, just plain old is, is another super common word in the English language. Every time you see it, it doesn't mean equals. But in the right context, the word is oftentimes means equals. Okay, and then we have this third part, which is not really a definition. It's just, excuse me, kind of a factoid. Hold on. Sorry, I got a piece of ice when I took that sip. Okay, so as I choke to death in this video, we have the word what. Okay, now again, the word what is a super, super common word in the English language. It does not always mean what it necessarily means here, but when you see the word when you see the word what, it often refers to the unknown value that you're looking for. So for instance, if I say, what is 20% of 50? Well, what is the unknown? Okay, so what? Well, what? In this case, what is? Well, is we can frequently associate with the amount. 20% is very obviously the percent, okay? And then of, we could usually associate it with the word multiply. And in this case, we know we multiply the base and the percent. So this right here would be the base. So in something really generic like this, we have three super common English words, but they mean something really important. What is the unknown? Is represents the amount. So what we're looking for is the amount. And then we have 20% of 50. That word of tells me that 50 ends up being my base. Okay, so yes, these are super common words in the English language, but they can mean really cool, important things for us in a math class. Okay, now we do have to assign a variable to the unknown. Okay, that is a common thing in algebra is you assign a variable to the unknown, and that's what we're going to be doing here. If we don't know what the amount is, we assign a variable to it. If we don't know what the base is, we assign a variable to it. If we don't know what the percent is, we assign a variable to it, and we will generally use the variables. I'll generally use A, B, and P for amount, base, and percent, but just please know variables X and N are really frequently used in problems like this as well. Okay? So let's go ahead and practice. We're going to do our first example here, and we're just going to kind of label the parts of these problems. So example 1 says, determine which value is the amount, the base, and the percent in each example. Well, for part A, it says, in a class of 30 students, 3 were absent today, which represents 10% of the class. Great. Okay, so what are these different parts to the problem? So we know the base is the entire quantity being considered. So we're talking in a classroom, there are 30 students. So 30 students is the entire quantity being considered. That's our base. And remember, the base is the entire quantity. Now, of those 30 students, 3 happened to be absent. So the 3 that were absent, well, that's going to represent the amount. It's some portion of the base. And then the 10%, that's the easy part. So 10%, that just ends up being the percent here, okay? And in this case, this percent represents the portion of the class that was absent. So 10% of the class was absent, okay? Part B, in a class of 25 students, 2 failed the final exam, which represents 8% of the entire class. Well, we have 25 students, and so that ends up being our base. We're talking about a class of 25 students, the entire quantity being considered would be all 25 students. So this is the entire quantity, so definitely our base. Unfortunately, 2 of these kids failed the exam, so we have 2 failed. Well, that's some portion of the base, very specifically 8% of the base. So this is the amount. Again, it's some portion of the base. And then finally, we know that 8% of the entire class failed. That's those 2 students that failed. So 8 is our percent. Okay, so that's kind of how you differentiate the amount and the base. The percent's always easy, but the amount and the base, really understand the base is everything. The amount is some portion of that. Okay, so in the next video, we'll look at writing out percent problems.